Welcome to the Explainer. So let's just dive straight into this, shall we? We are literally living through an explosive boom in artificial intelligence right now. And because of that, data marketplaces are absolutely surging. Platforms are popping up everywhere to feed this insatiable demand for high-quality machine learning data. But beneath this booming economy, there's a pretty chaotic reality. Nobody actually knows how to price this data. Today, we're exploring a fascinating open-source breakthrough from researchers at ZJU that was designed to solve this exact problem.
Here's our roadmap for this explainer. We're going to start with the data pricing paradox, then enter the DaDaDa dataset, look inside its architecture, talk about training and real-world applications, and wrap up with the future of data valuation. All right, let's go.
Part 1. The data pricing paradox. To really get why this new solution is a game changer, we kind of have to understand why the current system is just completely broken.
So, how much is a dataset actually worth? I mean, it sounds like a simple question, right? But seriously, ask any data scientist that today, and you're going to get a totally blank stare. This is the core headache for marketplace owners and AI developers right now. When you try to slap a strict dollar value onto a digital dataset, traditional economic models completely fall apart.
Think about physical versus digital stuff for a second. In traditional economics, you have the cost approach, right? You price a thing based on what it costs to manufacture it. But that completely fails for datasets, because copying a digital file is essentially free. The marginal cost is near zero. Then you've got the income approach, which is pricing based on the revenue you expect it to make. But that's a total bust here too, because a dataset's downstream return on investment is literally impossible to predict. The exact same data could generate millions or absolutely nothing, totally depending on the buyer's specific machine learning model.
So, because of all that, we are left with exactly one viable economic method, which is the sales comparison approach. You just look at what similar data sold for in the past. But here is the massive structural roadblock. There's no unified reference frame. The marketplaces out there are entirely fragmented. Buyers are facing these super opaque prices, sellers are just winging it with arbitrary heuristics, and there are basically zero standardized benchmarks across platforms.
Which brings us to Section 2. Enter the DaDaDa dataset. This is where researchers finally stepped in to bring some actual order to all this chaos.
16,147. Just let that number sink in for a second. That is the sheer, massive scale of data products captured in this brand new open-source dataset. Researchers meticulously scraped, cleaned, and compiled metadata for over 16,000 individual listings.
And they didn't just pull these from one place either. These were sourced across 9 major global data marketplaces. We're talking heavyweights in the data infrastructure space here, folks. Places like AWS Marketplace, Databricks, and DataRaid.
So that gives us DaDaDa. This is actually the very first open-source dataset explicitly designed to aggregate metadata and create a unified reference frame for data product valuation and pricing benchmarks. Basically, it provides that missing statistical foundation for the sales comparison approach we just talked about. It takes all those messy, fragmented listings and turns them into a highly structured training corpus.
Moving on to Section 3. Inside the architecture. Let's lift the hood here and look directly at the GitHub repo documentation and the data engineering pipeline that made this whole thing possible.
Now, building this wasn't exactly as simple as just hitting a download button. The team had to build a really rigorous data cleaning pipeline. First up, removing duplicates by cross-referencing title and provider fields. Next, rectifying errors, they wrote scripts to automatically strip out weird non-UTF-8 characters that were breaking file reading. And third, imputing missing values. If you're a data engineer, you know this is the truly painful part. Important details like data volume or update frequency are usually buried inside fluffy marketing text, so they actually had to manually annotate descriptions to extract and structure that missing info. Now, what's really interesting here is looking at the pricing models dominating these platforms right now. A huge chunk, 41.5% of data products, are just operating on a free model. But look at that second largest slice. 27.9% of products are locked in the negotiation tier. This is exactly that opaque, unscalable reality that DaDaDa is trying to fix. The rest is split between subscription, one-off, and usage-based models.
And if you're wondering on what kind of data is actually being traded out there, over a third of it, 35.3% to be exact, is retail, location, and marketing data. Financial services is right behind it at 22.8%. It gives you a really clear snapshot of the specific industries driving the commercial AI training market today.
All right, Section 4, Training and Real-World Applications. Because, having a clean data set is great and all, but how can data scientists actually use this in their production pipelines today?
Well, this unified schema enables three main engineering workflows. First, pricing model training, so you can actually predict fair market value instead of relying on arbitrary seller pricing. Second, product classification, using the metadata to automatically tag data sets even when platforms use completely different taxonomies. And third, retrieval systems. The researchers even included a retrieval prototype in their repo using Elasticsearch, so you can do semantic searches based on hard technical constraints, not just marketing copy.
Let's get a little technical for a second. If you're building classification systems with this, the researchers highly recommend fine-tuning multilingual pre-trained models. Their experiments showed that Hugging Face models like MBERT and XLM Roberta Large are super effective at generalizing across cross-marketplace metadata. They can understand the context regardless of which store the listing originally came from.
For the actual pricing tasks, you'll want to start with gradient-boosted trees or tabular transformers. These models are fantastic at handling the mix of categorical and numerical metadata you'll find here, and they significantly outperform raw neural networks for this specific job. Oh, and definitely remember to track your mean absolute error and root mean squared error, your reality check metrics, to monitor for any pricing bias.
If you're pushing this to production, there are a few best practices you absolutely have to follow. You need to normalize those schema fields before training for sure. Make sure you meticulously version your feature extraction pipelines and pin your dependencies, otherwise you're going to run into silent schema drift. But most importantly, treat this as a dynamic environment. Schedule periodic retraining with fresh listings. Marketplace metadata is constantly shifting, so if you don't update, your pricing model is going to be obsolete in just a few months.
And finally, Section 5, the future of data valuation. Let's zoom back out from the technical weeds and look at the big picture macro impact of finally having an open source pricing benchmark.
We do need to set the right expectations here. As the researchers point out, this dataset doesn't magically solve legal compliance or marketplace pricing policy all on its own. The best way to use DaDaDa is as a baseline estimator. You establish that statistical ground truth, and then you manually layer your commercial rules on top of it, things like volume discounts or enterprise negotiation tiers. It is meant to be a living benchmark.
So, I'll leave you with this thought. We've all heard the cliche for years that data is the new oil, right? But unlike oil, we haven't had a standardized global exchange rate or a clear price per barrel. Now, with open source tools like DaDaDa standardizing how we measure, search, and value data products, we are finally seeing the groundwork for a truly mature data economy. It really makes you wonder, as these pricing models get more accurate, who is really going to control the exchange rate of the AI future? I highly recommend digging into their GitHub repo to check out the raw metadata yourself. Thanks for tuning into this explainer, and keep learning.